Hello everyone, you're welcome to this channel once again. Today we have another peculiar question from the angle of aerodynamics. Now let's read through the following question. The flow past a cylinder that is positioned perpendicular to the flow will cause eddy downstream of the cylinder. This vortex shedding will occur at different frequency depending on the flow characteristics. In the case of incompressible flows, the shedding frequency F will depend on the 1. The cylinder diameter, 2. The free stream velocity, 3. The fluid density, 4. The dynamic viscosity of the fluid. Now, identify the fundamental dimension for all the parameters involved in this flow. Once again, the flow past a cylinder that is positioned perpendicular to the flow will cause eddy downstream of the cylinder. This vortex shedding will occur at different frequency depending on the flow characteristics in the case of incompressible flows. The shedding frequency F will depend on the cylinder diameter d, the free stream velocity v, the fluid density ρ, and the dynamic of the fluid μ. Identify the fundamental dimension of all the parameters involved in this flow. In today's question, let's assume that a cylinder with diameter d is subjected to a perpendicular flow with the V infinity, the density, the viscosity. And there's an healthy frequency shedding with the frequency K. Now, from the question, let's assume the vortex, which is represented here, that flow past the cylinder, will occur at different frequency depending on the flow characteristic. We are asked to identify all the fundamental dimension of all the parameters involved in this flow. So let's cite for an example. We have the frequency, we have the diameter of the cylinder, we have the flow velocity, we have the density, we have the viscosity represented here, and also we have the SI unit of them to be S raised to -1. Then the diameter will be meter, the velocity meter per second, and the density will be kilogram per meter cube, and the viscosity will be kilogram per meter per second. Now, we can deduce that the dimension, the MLT system system for the frequency will be T to raised to power -1. The MLT system for diameter will be L. The MLT system for the velocity will be L T raised to power 1, and the MLT system for the density will be M L -3, and the one for the viscosity will be M L -1 T -1. So to identify the fundamental dimension of all the parameters involved in this flow, we have all the values here to be the fundamental dimension system, or which we can call the MLT system. Thank you for staying tuned.